There are moments when everything we thought we knew begins to crumble, not in a sudden collapse, but in quiet revelations that leave us breathless. The kind of discoveries that don't shout, but whisper something so profound it echoes across every corner of our understanding. That's what the James Webb Space Telescope has done. It hasn't just looked back in time, it's reached beyond the story we thought we'd finished writing. And what it's found may break the very foundation of the Big Bang Theory. Launched into the black stillness of space in December 2021, the James Webb Telescope was designed to be the ultimate window into the past. With its gold-plated mirrors and unmatched infrared eyes, it promised to reveal the first light that pierced the darkness after the birth of our universe. It was supposed to confirm what many physicists believed was already settled, that the universe began 13.8 billion years ago in a blinding, chaotic explosion, and from that singularity, all matter, time, and space unfolded. But what if that wasn't the full story? What if the truth, quietly hiding in the faint glow of the earliest galaxies, told a tale far stranger, far older? As Webb peered deeper than any instrument before it, it uncovered something no one was ready for. Galaxies that should not exist. Massive galaxies. Complex galaxies. Galaxies so mature, so chemically rich, and so precisely structured that their very existence seemed to mock the timelines laid out by the standard model of cosmology. Some of these, like the now famous GNZ11 and CEERS 93316, appeared just 300 to 500 million years after the supposed birth of the universe. Cosmically speaking, a blink of an eye. And yet, they were already enormous. Some rivaled our own Milky Way in size and complexity. They weren't chaotic clouds slowly beginning to take shape. They had spirals, disks, central bulges, the kinds of features that, according to our best models, should have taken billions of years to emerge. But there they were, fully formed, graceful and defiant against the chaos they were supposed to come from. Scientists expected to see a slow climb from disorder to order, tiny primordial galaxies gathering mass over eons. Instead, Webb showed us the universe wearing its Sunday best, long before it was supposed to know what style even was. But it wasn't just the galaxies. The stars within them held their own secrets. For decades, astronomers believed that the very first stars, population 3 stars, were massive and short-lived, composed almost entirely of hydrogen and helium, untouched by the heavier elements created in stellar death. These early stars were meant to be pure elemental beacons of the young cosmos, but Webb's deep gaze found something different. In these ancient galaxies, the stars weren't pristine. They were already laced with heavier elements, carbon, oxygen, iron, the byproducts of earlier generations of stars. That means these galaxies didn't just exist. They had already lived, evolved, died, and been reborn. Multiple stellar generations in just a few 100 million years. According to everything we thought we knew, that's impossible. The timeline doesn't stretch far enough. The processes shouldn't have had time to unfold. It's like walking into a nursery and finding grandparents. And still, the mysteries grew. In the heart of some of these galaxies, Webb found something even more unsettling. Supermassive black holes. Not just large black holes, enormous ancient monsters with masses hundreds of millions of times greater than our sun. They existed in galaxies less than 700 million years old. Some, like CEERS 1749, formed so early in cosmic history, it's as if they skipped the line entirely. Our models suggest that these giants should take billions of years to form through gradual mergers and relentless accretion. But these were already there, already feasting on gas, already shaping the galaxies around them. How did they grow so fast, or were they simply always there? With each new discovery, the neat scaffolding of the Big Bang Theory and the lambda cold dark matter model began to shake. The LCDM model, our gold standard for explaining the universe, depended on a universe that was born in fire, cooled over time, and gradually built the structures we now see. But what Webb showed us was something else entirely. The early universe wasn't chaotic enough. It was too smooth, too organized. Galaxies were rotating in ordered disks. Clusters formed elegant filaments across space. The turbulence we expected from the aftermath of a universe-wide explosion just wasn't there. It was as if someone had skipped ahead in the story. Even the clouds of gas Webb observed weren't what they were supposed to be. At redshifts that correspond to the first few 100 million years after the Big Bang, we should see untouched clouds of hydrogen and helium, primordial matter untouched by time. But instead, many of these clouds showed traces of metals. They weren't pure. They weren't young. Some process or history had already changed them. And if that wasn't enough, their structure, their shape, their behavior defied expectation. Filamentary lines stretched through the cosmos, suggesting some kind of underlying order that we were never supposed to find this early. How? That question began to echo louder through the halls of physics departments and observatories around the world. Because if these findings hold, and they're being confirmed at a steady pace, then the Big Bang Theory, as elegant and powerful as it once was, may be only a chapter in a much larger, stranger, and older story. The redshift, the method by which we estimate the age and distance of cosmic objects, has become a topic of renewed debate. For decades, we believed that the farther light traveled, the more it stretched, shifting to red as space itself expanded. But if these ancient galaxies are already so evolved, could it be that redshift doesn't only tell us about distance and age? Could it hint at something deeper? Could the light be changing not just from expansion, but from something else entirely? The tired light hypothesis, long thought obsolete, is now back on the table in some circles. In that view, light loses energy as it travels, not because the universe is expanding, but due to unknown interactions along the way. It's a radical idea, one that would force us to question everything about our measurements of time and space. Suddenly, cosmology isn't just about studying the past, it's about rewriting it. And this is only the beginning. The universe, as seen through the eyes of the James Webb Space Telescope, is not a dark, formless void slowly waking into existence. It is vivid, structured, and startlingly self-possessed, even at what we assumed were its earliest moments. This wasn't supposed to happen. The galaxies Webb captured, massive and mature, spinning with grace and laced with the chemical fingerprints of previous generations, aren't the fledgling fragments predicted by the standard model of cosmology. They are old souls in a young sky. Their very existence within just a few 100 million years of the supposed Big Bang throws a wrench into the gears of the lambda cold dark matter model that scientists have used for decades as the backbone of cosmic understanding. Imagine looking back in time, not millions but billions of years, and expecting to see the nursery of the cosmos, a chaotic realm of stardust and possibility. But instead, we see ancient black holes already devouring matter, with the hunger of something far older than the calendar allows. We see stars glowing not just with raw hydrogen, but with the fingerprints of iron, carbon, and oxygen, metals that should only exist after countless cycles of star birth and death. These are stars with stories, with ancestry. Yet the universe was supposedly too young then to have written even the first chapter. What Webb is showing us isn't just an observational anomaly, it's a cosmic betrayal, a betrayal of the neat, elegant assumptions we made about time, creation, and structure. It suggests the timeline we trust might be broken, compressed, or worse, misread entirely. Could it be that our cosmic clock is ticking to the wrong rhythm? That redshift, the expansion-driven stretching of light that tells us how far back we're looking, doesn't mean what we thought it did. Some scientists are beginning to whisper about tired light again, an old, mostly discarded idea that redshift might not be caused by galaxies rushing away from us, but by light itself gradually losing energy as it traverses the great cosmic sea. If that's true, then perhaps these ancient-looking galaxies aren't as young as we thought. They might not be young at all. They could be older, even timeless. Their red light a symptom of distance and age measured not by expansion, but by endurance. It's a radical thought, one that threatens to topple everything we built on the notion of a rapidly expanding cosmos. And what about inflation? The idea that the universe expanded exponentially in its first fraction of a second smoothing out its initial chaos. That too is under fire. If inflation smoothed the wrinkles of the universe into the evenness we see in the cosmic microwave background, then how do we explain the lumpy, structured, exquisitely balanced formations that Webb sees at the supposed beginning of time? It's like discovering a mature forest on a planet we thought was just born. Trees take time, ecosystems need eras, and yet there they are, galaxies with arms, symmetry, and supermassive hearts that shouldn't beat so soon. Even the cosmic microwave background, the soft, ancient glow that cradles us in every direction, starts to feel suspect under the weight of these findings. It once told us the story of a gentle infancy, where matter cooled and spread, eventually giving birth to stars, galaxies, and black holes. But if those structures were already present, vibrant, and fully formed far earlier than we thought possible, what exactly are we looking at in that background light? Is it a remnant of something older still? Or have we misunderstood the very conditions it represents? Dark matter, once the silent scaffolding of galaxies, now finds itself under scrutiny. The standard model assumed that galaxies formed within halos of dark matter that pulled in gas and dust, guiding their growth like invisible hands. But if galaxies are forming too quickly, with complex structures arising before these halos could logically develop, then maybe dark matter isn't the architect we believed it to be. Or maybe we've missed an entire part of the story, some hidden mechanism or ancient force that builds with the urgency of memory, not time. And looming behind all of this is the Hubble tension, the growing mismatch between how fast we think the universe is expanding based on early observations versus how fast it appears to be expanding now. Webb's discoveries widen that gap. The more we measure, the less the numbers agree. It's as if the universe is playing a trick on us, holding up mirrors and echoes that don't align no matter how we turn them. In the face of all this, alternative ideas are gaining traction, not because they are new, but because they offer answers where the old models can no longer stretch. The Big Bounce, for instance, suggests a cosmos without a beginning, where each universe is born from the ashes of the one before. In this view, the complex structures Webb sees might be echoes, residual architecture from a universe that collapsed and gave rise to ours. It's an idea that feels ancient, almost mythic, but it's being explored seriously in the language of quantum loops and mathematical symmetries. Others speak of a steady state, a universe that simply is, eternal and ever regenerating, with no origin to trace. Here, galaxies aren't early or late, they just are, coexisting in a cosmos where matter and energy cycle endlessly. And then there's plasma cosmology, where electric currents and magnetic fields play as large a role as gravity in shaping galaxies and stars. In this vision, structure arises not from gravitational collapse over eons, but from the dynamic dance of charged particles weaving galaxies in lightning-fast strokes. Or perhaps the answer lies in the quantum realm, in emergent space-time, where space and time themselves are illusions arising from deeper, unseen principles. String theory and loop quantum gravity suggest that what we see, the stars, galaxies, and timelines, are projections from a higher dimensional truth. In this framework, time might not flow at all, and the early complexity isn't surprising. It's simply what was encoded in the cosmic hologram all along. What's clear is that the James Webb Space Telescope has done more than just look back in time. It's broken something, or perhaps revealed something we hadn't dared to see. A fracture in the glass through which we've been watching the universe, one that forces us to reconsider not just how it all began, but whether it began at all. The more we see, the more we question. And the deeper the questions, the more we begin to suspect that the story of the universe is far stranger, older, and more alive than we ever imagined. What happens when the origin story of everything unravels? What do we do when the cosmic script, the Big Bang, the expansion, the silent void exploding into light, begins to sound less like truth and more like a comforting myth we told ourselves in the dark? As the James Webb Space Telescope peels back the layers of time, revealing a universe that seems too mature, too intricate, and too intentional for its supposed age, we're left standing on the crumbling ledge of certainty, staring into a new kind of abyss, not one of emptiness, but of overwhelming complexity. Scientists, once united in the elegant geometry of the Standard Model, now find themselves divided. In hushed conferences and late-night video calls, astrophysicists and cosmologists debate whether they are witnessing a crack or an entire collapse. The Webb images are forcing a reckoning, and in that reckoning lies the possibility of a scientific revolution, one as profound as anything since Einstein bent time and space with his equations. At the heart of this revolution is a single terrifying thought. What if time isn't linear? What if what we're seeing isn't the past, but something else, something not bound by our perception of cause and effect? Could these galaxies be leaking through from another phase, another cycle of the universe, or even from parallel realities that have always existed alongside our own? The Webb telescope may not just be a time machine, it may be a mirror reflecting dimensions we never imagined we were part of. Quantum physicists have long whispered about the multiverse, about reality as a field of infinite outcomes and hidden connections. But now those whispers are becoming a chorus. If time and space are emergent properties, constructs that arise from deeper quantum information, then perhaps what we're witnessing is not the birth of the cosmos, but its interface. A kind of cosmic operating system revealing its code not in the form of equations, but in spirals of galaxies and the metallic breath of ancient stars. Patterns too deliberate to be accidental. Structures that suggest intention or intelligence. This is where science begins to blur into something else, something older than equations, myth, philosophy, the soul's deep instinct that there's more to the cosmos than chaos. Because if these galaxies are too old, too composed, then the very laws that govern entropy, disorder over time, are being challenged. The universe isn't winding down. It appears to be holding shape, resisting decay, resisting simplicity, as if something or someone wants it to. Naturally, this is controversial. Most scientists are cautious, and rightly so. They insist that extraordinary claims require extraordinary evidence. But others are beginning to consider what was once unthinkable, that the universe is not a fluke, that it was not birthed from randomness, but designed, consciously, recursively, and possibly for a purpose. Enter the simulation hypothesis, once fringe, now unsettlingly plausible. If Webb is seeing a cosmos that appears rendered from the first pixel to the last, then maybe that's exactly what it is, a rendering, a simulation whose fidelity is so high that only a telescope this powerful could begin to detect the edge, the limit of resolution. Could the odd alignment of cosmic structures, the impossibly smooth patterns, and the repeated mathematical ratios be signs of a system operating within constraints? Bound not by physics, but by code? We used to think of the universe as a machine, then as an organism. Now perhaps we must think of it as a program, one whose source code lies not in space but in information itself. And if it's a program, who or what wrote it? That's not just a metaphysical question anymore. It's becoming a scientific one. Because the more we observe, the more the universe begins to look like a fractal, a self-replicating pattern written into every scale, from the arrangement of galaxies to the swirl of a seashell. This recursive logic is not random. It's ordered, structured, and it implies memory, cosmic memory, not just of what has happened, but of what could. Suddenly, ancient texts and myths that spoke of cyclical time, of eternal returns and forgotten ages, don't seem quite so naive. The Vedic concept of kalpas, the Mayan belief in great epochs, the Stoic idea of eternal recurrence, what if they were echoes of a truth lost to time, but etched into the fabric of the cosmos itself? What if the ancients, in their symbolic language, were describing what Webb is only now beginning to see? And what does it mean for us, tiny flickers of consciousness orbiting a yellow star in a spiral galaxy that may be older than we dared to hope? If the beginning is no longer the beginning, then perhaps we are not latecomers. Perhaps we are participants in something vast and ongoing, a story without a first page, a cycle in motion. This realization is as liberating as it is destabilizing. It means our role in the universe might not be incidental. If the cosmos is coded, if consciousness matters, then observation matters. What we see, what we seek, may shape what the universe becomes. Just as the act of measuring a quantum system collapses its potential into reality, maybe our gaze into the deep past is doing more than just seeing. Maybe it's awakening. In the wake of the James Webb Telescope's revelations, the lines between astronomy, consciousness, and existential philosophy are dissolving. We are no longer just studying the universe. We are being studied by it, reflected in it, called by it. So where do we go from here? We can no longer pretend that the cosmos is a simple machine wound up and left to tick. We can no longer cling to a model that refuses to hold under the weight of the evidence. We must open our minds, not just to new physics, but to new ways of thinking about reality itself, about time, about purpose, and about the strange, almost poetic fact that we are able to ask these questions at all. Because maybe, just maybe, that's the point. Maybe the universe evolved not just to produce stars and gravity, but to produce beings capable of wonder. Maybe the galaxies aren't the miracle. Maybe we are. And maybe the final discovery of the James Webb Space Telescope isn't out there among the stars. Maybe it's within us, the realization that the cosmos is not just a place we observe, but a mystery we are meant to live.